Good morning, Boston. I'm Rebecca.
And I'm Michaela. Today in Boston, Massachusetts, the temperature is 40 degrees Fahrenheit with a wind speed of 5 miles per hour, with winds traveling west to northwest, with partly cloudy sky conditions.
The humidity today in Boston is at a high 80%. The lower the temperature, the lower the dew point. And because of our low temperatures of only 40 degrees today, our dew point is only at a 15 degrees. The dew point meaning that the temp to which our air is saturated. Now, on to Stephanie with air movements and pressure systems.
All right, I'm Stephanie. So global wind patterns create huge bodies of air. These are called air masses. This is what moves west to east across the country. When we have two air masses, this is called a front. These also move across the United States. When you see fronts on a map, they are represented by colors. Cold is shown in blue and hot is shown in red. As you see on our air front map, that's what we have. The air is not equally heated by the sun, so pressure varies. Warm air creates lower pressure systems because the warm air rises. This creates the low pressure system. It's the same for high pressure. This is when the system has higher pressure at its center more than areas around it. Low pressure is shown in a red L and high pressure shown in a blue H. Here we see that in the Midwest today. On the West Coast. Pressure for today is 1,029 millibars. Luckily for us in Boston, all pressure systems are in the west today, so it doesn't really affect us. There are no storms for today in Boston. Most radar maps we see online or in the news are Doppler radar. These types of radar are used to show precipitation. Radar will show you everything you need to know. It calculates motion, the type of precipitation, and intensity. Now on to Caitlin with our mixing ratio.
Hello, I'm Caitlin Kendall, and today I'm going to show you how we're going to calculate humidity using a relative humidity equation. So this equation, relative humidity, is RH, and that equals your mixing ratio over your saturation mixing ratio. This will get you a decimal, so you're going to times it by 100% to give you a percentage for your humidity. However, we know that it is 80% humidity in Boston today, so 80% in decimal form is 0.80, so relative humidity is 0.80. We don't know our mixing ratio, that is our variable x. But our saturation mixing ratio, we use a chart and it tells us based on the temperature what number to use. So we know it's 40 degrees today, so we are going to use 5.2 for our mixing ratio. To solve for x, we're going to multiply. So we do 0.80 times 5.2. That number is 4.16. So 4.16 is our mixing ratio. Now that we know that, so our 80% humidity, you can tell that it's pretty wet out there. Looking at our radar, we see there's a lot of precipitation here, but if you zoom in on Boston here, which we're gonna try to do, you can see it's pretty dry. There was some rain this morning. It's dry right now, and looking forward, it's looking dry as well. But now we're going to move on to Katie for some weather station.
Weather station.
Yeah.
All right, hi, I'm Katie Adrians, and today I'm going to talk to you about the weather station. So, using this here, I can show you guys how we set up our weather stations. So we're going to start out with how the sky looks. Today we have 94% cloud coverage, so we have a little sliver in the middle, and it's 40 degrees Fahrenheit outside with a 15-degree dew point. And our pressure is at 1029.71, and it's shown as 29.71. And we have wind coming from the northwest at 5 miles per hour, and it's shown by that. Based on what we've seen so far today, we can tell that looking forward it's going to stay pretty dry. The temperature will go down a bit and it'll pick up wind a little, but we have nothing to worry about. So thanks for watching.